Thanks, Mike. Appreciate the introduction. Thanks to the Northwest Wisconsin Lakes Group to inviting us to be back with you again. Let me start with a question. Are all of you aware of what a wakeboard boat is? Pretty much. And are all of you aware of what a wakeboard does when it goes into wake surf mode? Okay, so I'm going to make sure that I describe that to you. Charles is an electrical engineer, retired now with Terra Vigilis. Terra Vigilis is a group of retired military officers, PhD academics in the various sciences and engineer types who agreed to get together kind of on a hand-picked basis and address.
A little closer.
Okay, was that better? Maybe the battery went kaput.
The batteries going.
Okay, you can hear me a little better? All right. So Tim Tyre and Charles Luebke from Terra Vigilis Group speaking with you as Mike explained about our phase 2 findings, portions of our phase 2 findings. The Terra Vigilis Security Group and Environmental Services Group is a composite of retired military officers, mostly aviators, engineers, and PhD scientists in the various disciplines that were handpicked to get together and manage threat. We started out and continue to work with critical infrastructure, so nuclear power plant facilities throughout the United States, other places where threats are an issue. And it's from that lens that we viewed threats to lakes. And so we developed an environmental services division within our group. This is a funded piece of research from the DNR, and it has 3 phases. And we're going to talk about some of the findings from the second phase, which was last summer. Let me start by telling you a story about the United States Supreme Court, of all things. In 1964, there was a landmark case that the Supreme Court took up dealing with the vexing problem of defining hardcore pornography. They had a very difficult time doing that. And one of the chief justices at that time, Potter Stewart, generated a now famous quote that went a bit like this. After all the review and the testimony, I have a difficult time coming up with a good written definition of hardcore pornography, but I sure know it when I see it. Anyone who lives on a lake or has observed wakeboard boats, particularly in surf mode, knows about the surface effects of wave enhancing equipment, either built into the manufacturing capacities of a wakeboard boat or as an add-on even to a pontoon boat. So these are specifically engineered systems to produce displacement waves, which are very large. And in particular, from what we see from a shoreline, they have surface impacts on other vessels and on near shoreline. Some of what we have studied is the science associated with how far out those waves propagate and their impacts on the water column and water quality. But we've also looked at subsurface impacts, and that's some of what we're going to chat with you about today. Charles and I will go back and forth depending upon what we're looking at. So, as this slide would indicate, we were retained by the North Lake Management District, which is a organization that protects the waters of North Lake, which is the northernmost lake in Waukesha County in the watershed that extends all the way down towards Jefferson County in southeast Wisconsin. North Lake is about 440 acres. I'll show you satellite photos in a little while. There's a large lake basin, locally referred to as the Big Lake, and a smaller lake basin referred to as the Little Lake. The Big Lake Basin is about 340 acres. The Little Lake is about 110 acres. So the combination of the two together is 440 acres. We got started there in 2019 with the formal study. We were concerned about the impact of wave enhancing vessels for a number of years prior to 2019. Charles and I together have lived on that lake 40 years for my wife and I and kids. Much longer than that for you, right? 60 years for Charles. So this is a lake we have personal interest in and have watched changes over many years occurring on the lake. So about 7 or 8 years ago, North Lake had 3 or 4 wakeboard boats. And the 3 or 4 that operated on the lake back in about 2014, 2015 became a cause of concern for lake owners on the lake because of the large waves and the impacts on the near shore and on other boats. And the riparian owners on the lake, of which there are 240, through the North Lake Management District, put together a survey and wanted to know what people wanted to do about these wakeboard boats. And the survey had almost an 80% return rate, which is unheard of for a survey. And there was great concern about the impact of the boats. This is back 2014, 2015. Last summer, the boat count on this 440 acre combined lake is 41 wakeboard boats. The Little Lake, which is about 110 acres, as I indicated, has over 20 of those wakeboard boats. The rest are on the larger lake. So it is a problem which is increasing. My personal interest and the interests of our group was to try and bring some science to what is very often a very contentious and conflicted topic. Because the people who own these boats, who typically pay anywhere from $150,000 to $185,000 for one of these vessels, are unaccustomed to being told no, or adhering to reasonable limitations and guidance. The majority of them are uninformed about the impact of these vessels. And so our group became interested in developing some of the science that could inform ultimate public policy about protecting this lake. So this lake is a kind of a microcosm for something that's happening not only throughout Wisconsin and the Midwest, but all across the United States. So as we move through some of our data with you today, you'll hear us pause and make reference to other studies which are interestingly showing very much the same findings on wave impacts, wave energy, prop wash, and its reach down to the subsurface of a lake. So 2019, we began this formal study. The scope of the work included gathering metrics on water quality markers, and I'll go through the chemistry on that with you in a little bit. We used both commercial, aerial, and subsurface drones. So in our group, we have not only, I'm a fixed wing pilot and flight instructor, but we also have commercial drone pilots. And so we use drone technology, which provides very compelling images, which I'll show you in a little while, that Potter Stewart would have enjoyed. It's a 3-phase study. And it is a collaborative study between Carroll University in Waukesha and its departments of chemistry, environmental science, and aviation science, as well as the Southeast Wisconsin Regional Planning Commission, which is populated with PhDs in marine biology and limnology, and our research staff within Terra Vigilis, as well as the North Lake Management District. The study that was funded includes measurements of water clarity and chemistry, redistribution of lake bottom sediments, the development of plumes from wakeboard boats in surf mode in particular, and I'll define that in a bit for you. Measurement of wave enhancing prop wash impacts, so the downwash from propellers from wakeboard boats in surf mode, and then near shore erosion data, baseline data. We also did a survey of aquatic plant species using some of the submersible drones that we have, and we're not going to focus on that today. This is a span of some of the academics that came out of Carroll University that put their hands up to participate in this study. I was surprised when this happened because we had Drs. Rivera and McCarthy from the Department of Business and Applied Business Analytics. So why would business professors be involved in a study of this type? Because water quality, as Ted Relza well described this morning, has a direct impact on property value. If a lake is suffering, property values go down. If a lake is pristine, property values maintain or go up. And these professors were particularly interested in that. In addition, we had several interns from the Chemistry and Environmental Science Department over there at Carroll University, as well as two primary senior scientists from the Southeastern Regional Planning Commission and members of our group. A couple of the drone pilots. Charles, as I indicated, is an electrical engineer, very smart fellow. And he and I and Mortensen have been the principal investigators really on this study. So let's pop ahead to a quick satellite image of North Lake. So the larger lake runs about 1.25 miles long, about a 1/2 mile wide. The smaller basin lake to the left, as you look at this slide, is 108 acres. It's about a 1/2 mile long and about not quite a 1/2 mile wide. The lakes are deep. The large lake has deep holes of almost 80 feet, as does the small basin lake. There are 3 inlets, so this qualifies as a drainage lake system. So the inlets up at Site 6 and Site 5 come from the Oconomowoc and Little Oconomowoc rivers and something called Mason Creek. Those rivers have agricultural runoff that come down into the lake. Near Site 7, we have an inlet, a small inlet. Over near Site 4 on the Little Lake, to the left of the S, the capital S, there's an outlet that moves down through the Oconomowoc River into the lakes that are below us. So Okauchee Lake, Oconomowoc Lake, and so on. So what happens in North Lake touches all those other lakes down the watershed, which got the attention of the Oconomowoc water people, the sewage treatment people. So some of the choices of measurements of water chemistry were influenced by the sewage folks. So let's go back. So we had 7 sampling sites on both the large and small basin lakes. We looked at total phosphorus, total suspended solids, dissolved oxygen levels at various depths, and temperatures at various depths. We had water quality measurements, including dissolved oxygen, at staggered depths throughout the lake. We did use standard Secchi disc procedures for measuring water clarity. And last summer, we spanned not quite 13 weeks of sampling from June through September, so late spring and early fall. All of the chemistry sampling went to state certified labs. following their procedures on cooling it and maintaining it and preserving it. We use commercial aerial drone and commercial submersible drone systems for looking at both plume development and wave features, in addition to looking at underwater impacts, which heretofore had not been done. Now there's been some study done out at Payette Lake on the West Coast, and the University of Minnesota study that Jeff Marr at St. Anthony Lab is heading up is also about to look at downwash as well. We established based on temperature readings, the thermocline levels throughout the lake. And then we did an interesting little sub-study on the release of phosphorus after runs of wakeboard boats in surf mode on a predetermined course, pre-post testing of phosphorus release. So that's what we're going to kind of give you. Now, before we get a whole lot further into this, let me define what a wakeboard boat is in surf mode. So wakeboard boats are large vessels with very powerful engines, anywhere from 450 to 500 horsepower engines. When they go into something called surf mode, they have a capacity to flood the stern. That's the back end for you non-Navy types, right? So they flood the stern with anywhere from 4,000 to 6,000 pounds of ballast, water ballast. As that stern is flooded, it drops down into the water in an angle, which brings the bow up. So now the bow is up at about a 15-degree deck angle, which makes visual observation by the operator of the vessel questionable. And they operate at a very low speed, about 7 or 8 knots, which means they are producing a very large displacement wave, which propagates out on either side of the stern on the surface as you see it. In addition, if you know wave physics, you'll know that the energy that is generated by this displacement system also pushes subsurface impacts. And again, as I told you, we're going to look at some of that. So that is a wakeboard boat in surf mode. When they surf behind this, they literally are on a small surfboard. There's no rope. They're within 4 or 5 feet of the stern of the vessel, and they're riding back and forth on this big wave. It's not a form of water skiing that takes great skill. So many people can enjoy this. So that's a wakeboard boat in surf mode. When we talk about wakeboard boats operating with significant wave impacts, we're talking about those boats used in surf mode. Okay, so there's our 7 sites on both lakes. Now let's talk a little bit about some of the measurements we took of wave propagation and the physics associated with that. So how do we measure it? The first 3 procedures, I won't get into lots of detail on, except to tell you that all of it was digitized. We did use aerial drones to have a look down capacity, which could then be turned into a wireframe model. So we had very, very precise measurements of wave heights and troughs and distance between crests. In addition, we engineered a system about 40 feet from the shoreline where we took most of our wave energy measurements that involved a surveyor's rod attached to a dock in about 4 feet of water with a hovering drone at about 2.5 feet off the surface that was taking continuous stream pictures of waves as they rolled past the surveyor's rod, which was giving us changes in wave heights in inches. The 4th method of measurement involved something we engineered at Terra Vigilis, and I'll show you a picture of it in a moment. In fact, let me show you the picture now. Yeah. So this was an engineered system for measuring downwash from a propeller from wakeboard boats in surf mode. We also used it to measure downwash, what little there was, from conventional boats, fishing boat, pontoon boat, personal watercraft boats, which do not produce appreciable downwash. By that, I mean less than 3 feet, because the vortices that come off that propeller are horizontal to the surface of the water. A wakeboard boat in surf mode is at a down angle on the stern, and so the prop wash goes down at anywhere from a 40 to 50 degree angle. So this piece of engineered hardware extended 30 feet. If you look at the bottom left-hand corner of this photograph, that camera would have been on the bottom. Every 5 feet, there's a fixture with a fiber optic wand at the end and a camera with lighting. So when this was extended on the vertical axis and anchored, those fiber optic wands would respond to downwash energy from the propeller of the whatever vessel went by. And so we have photographs, streaming video of the impact of these propeller downwashes. So let's go back. These data are a reflection of our measurements of wave height and wave distances with the methods that I described to begin with. So the surveyors pull a drone about 2 or 3 feet off the surface, taking continuous measurements of wave height as it passed over that fixed scale. And I'm going to get Charles to describe some of these data to you so you can appreciate what these wavy lines all mean. Oh, there.
So for the 3 charts or tables with all the numbers, basically as Tim described, we digitized looking at the wave height over time. And so we did it for wakeboard boats, pontoon boats, personal watercraft, or jet skis. A lot of numbers, but the data behind it we could put in graphical form, and that's what you see at the bottom, again represented as the wave height and shape and length, wavelength for a wakeboard boat, a pontoon boat, and a jet ski. And you can see the inherent difference, particularly on the leading edge of this wakeboard boat wave with a significantly higher peak. And so by looking at that, not only is the wave higher as you see it approaching, but the physics behind it is that when you double the height of a wave, you actually have the square of the energy is actually the square of that. So if we go from a 2-inch wave to a 4-inch wave, we're not just doubling the energy, we're making it 4 times more energy in the amount of power or energy that's in that wave as it propagates. So you can see that for a wakeboard boat, not only is the peak higher, but the wavelength is typically longer as well compared to the other boats. And that also translates into more energy at the surface, but also below the surface. So as this higher energy wave reaches basically the what we consider the drop off or the shallow area, that energy that's in the water below the surface has to go somewhere because the water depth is decreasing, so that energy actually pushes the wave up, and you would typically see this as the waves getting higher and ultimately breaking as they get into shallow water. So the next thing we did was look at those wave heights and peaks and troughs and the wave shape or oscillations at different distances, with the boats being driven different distances from shore. So in this particular example, we had 4 simultaneous measurements going on, as well as video from above at approximately 400 feet above the water. You can see in the upper left, this wakeboard boat is going to be coming by the shoreline. The lower left is from the shoreline looking out at that same boat. So these are all synchronized in time. On the upper right is this surveyor marker with a camera to actually measure the wave height. And then the lower right is actually this representation graphically of what that wave looks like over time. So if I play this video, it worked a minute ago. Any way of replaying that? Look, okay. There we go.
This is the one that's 250 feet from shore, right?
Yeah, you want to narrate this?
Yeah. By the way, so there's a wakeboard boat in surf mode, top left. The end of the pier with the little personal watercraft attached to the dock. You see the wave moving in now, top left. You're not going to see much impact on the surface until it gets a little closer in. "200 feet from shoreline is kind of a standard requirement on most lakes. Here's the waves coming in. Now you see the difference on the surveyors. And again, we're measuring this at the surface of the water across, which is what gives us the oscilloscope recording. Okay, let's go to the next one now. Here,
No, just click on this to get back to the presentation.
which one?
The slash. Go to the right. So now you can advance the slide.
Okay. So now we're going to go 300 feet. If you talk to the retailers who sell these vessels, they'll say two things to people buying them. One, the waves produced by these vessels are no different than any other speedboat. Two, they disappear within 200 or 300 feet from the boat. This is 300 feet from the shoreline. We also did 400 feet, but the data got corrupted, so we're going to rerun that again this summer. So this is 300 feet, same vessel, except they're 100 feet further out. Top left, moving in towards the shore. Top right, you'll watch the surveyor's rod as the wave passes across it. Again, we're digitizing all this. So here comes the wave. Similar impact, 300 feet out. Our raw data that we didn't depict here today looks at 400 feet out. You get a similar effect, a little bit less height. The University of Minnesota study done at St. Anthony's lab demonstrates 500 feet where you still get significant wave energy. So those are surface impacts that you can see with the naked eye standing on the shoreline. This explains why property owners on many lakes in Wisconsin that have these vessels operating are unhappy, and will tell you anecdotally about how their boats on a lift near the surface of the water get lifted up and banged down, or grandkids get pushed over. These are large waves. They're very different than the kind of waves that are produced from other vessels, which have a planing hull. So the energy dissipates because it's not a displacement wave of any real significance. Now, the next series of images we're going to show you relate to that engineered pole. So now we have a standard course set up with a wakeboard boat in surf mode. This is a 2021, I think, wakeboard boat, super ski nautique boat. So this is the biggest one they make, with computer enhanced capacities to move that stern angle up and down, to move the ballasting around from port to starboard, and to control the speed to produce an optimal wave. The computer software on these vessels allows them to produce a, quote, optimal wave and to shape the wave. So we want to get to, oh, by the way, before I play that, what you're going to see, if you look at top left photograph here, this is looking out across one of those extended arms at 14 feet, then at 17 feet, and at 20 feet below the surface. And then you've got a camera on the bottom looking up. So imagine that you're laying on the bottom with your eyes looking up that pole to the surface. Okay, so here comes the wakeboard boat on the course. Top left, you don't see the fiber optics doing anything because it hasn't arrived. There's no energy yet being dispersed down. As it gets close, you're beginning to see some pushed reaction. Now he's right past the buoy. That's the top of the system. 14 feet, 17 feet, 20 feet. A picture is worth 1,000 words. Of interest, this is exactly what they got out at Payette Lake in Oregon. And this is what the University of Minnesota is going to address with a Doppler measurement system, which is a little different than our imagery, but will produce a similar data impact. We took these data and computer enhanced it so people could understand a little bit easier what's actually occurring. So the image that you're looking at here is based on the bathymetric data of North Lake, the Little Lake Basin where we did our study. So there's a wakeboard boat in surf mode, configured at surf mode. So the angles relate to surf mode as I described it. There are the various depths. There's the downwash. There is a measured thermocline level on that lake. And if you all know about thermocline levels, that's dense water, cool, designed by the good Lord to protect the bottom as a kind of a blanket. Now, our study did not address in a systematic way penetration of thermocline with redistribution of sediment. We only saw that secondarily by the development of plumes. So I couldn't say with scientific precision that these are actually penetrating thermoclines. I can tell you indirectly, where else would the plume be coming from except by penetration of the thermocline? I indicated that we were also interested in what happens when these vessels are used in terms of changes in water column chemistry, specifically phosphorus. So in other words, does the prop wash stir up the bottom sufficiently to resuspend phosphorus in the water column? So this was also a study that we did on the same lake, on the Little Lake. We set up a course, which was about, I think 500 meters long, about 1,200 feet long. So site A, site B, site C, those together, probably 1,000 feet. It was set up specifically 200 feet from the shoreline, which is the guideline. The water depth there ranges from 20 to 25 feet all the way up to about 15 feet at the north end. You're looking at a photograph with north at the top. So we set up a wakeboard boat in surf mode for 2 runs to go up that course and back down. So up counts 1, down counts 2. 2 runs, that's all. We did it early in the morning on a calm water morning. We took phosphorus dips before the run and after. 25% increase in phosphorus in the water column within 30 minutes. That's 2 runs. That's not all day. And it's not a bunch of these vessels in one place. Draw your own conclusions. I'm going to take questions here in just a minute. Well, go ahead. Yeah.
Is that a total phosphorus or a marginal phosphorus?
It's a total phosphorus. Yep. We took phosphorus sample levels throughout the summer at site 3. Site 3 is this site. If you look at where buoy site C is, and you go across what they call Wildwood Point Road, just across it, that's a reef that gets as shallow as about 8 inches and then drops off into the big lake. That's site 3 on the side of the big lake. So at site 3, we took phosphorus throughout the summer using the WDNR standards at 0.015 milligrams per liter across all those sampling dates. We were in excess on the lake. And this is a clean lake. This is considered a clean lake. Site 3 was chosen because it's a transfer site for plumes that run along the shoreline on the little lake when it's stirred up and they jump across Wildwood Point. I'll show you a photograph of that in a minute. So now we're going to show you another video that was taken in 2020, which shows the development of these plumes. The orange arrow is showing you where it jumps across. So the end of the greenery is the beginning of the reef that runs up about maybe 1,200 feet. And then there's another point way up at the top of the slide. That's where the boats move back and forth between the 2 lakes. So along the edge of the reef, the water is anywhere from 6 inches out to about maybe 4 or 5 feet, and then it drops off. So this little lake and the big lake are just great big bowls. One of the distinctive features of this lake is that all around the perimeter, particularly of the smaller lake basin, there is a shelf that runs out about 100 feet from the shoreline that's shallow. It's only 2 to 4 feet, and then it drops off precipitously. So when the wave energy that Charles spoke about is generated subsurface, so the displacement wave is produced, you have energy going up and over the surface of the water that you see. You also had energy spinning down below. As long as it's not scrubbing the bottom, it gradually loses its energy. But as that propagates away from the vessel towards the shoreline, as the water shallows out and it gets up on that shelf, the wave reemerges. As it reemerges, which you can see from the surface, where did that come from? It also scrubs the bottom. And as it scrubs the bottom, it creates these visible plumes. Again, this was taken from a drone at 400 feet AGL above the ground level. And it runs the shoreline and then jumps over that reef and redeposits on the other side. So one of the things we did 2 summers in a row was we took a look at the condition of that reef anywhere from 8 to 15 feet below the surface with a submersible with a camera and a very powerful lighting system. In late spring, it's pristine along that reef on both sides. Towards the end of the summer, after this continuous redepositing, it's covered with a kind of a muck that appears to smother out all of the aquatic plant life. So we want to show you a video that demonstrates this. You want to give me a hand on this part?
It's like this is 31.
Yeah, we got to go to 31. You did that before.
Well, good afternoon, everyone, and welcome to this next.
Why is it not letting me grab the? There we go. Why isn't it not letting me grab it?
Session of the 2021.
It's not letting me grab the time bar. There we go. Got it.
Pilot error.
As sometimes happens in science by serendipity, and that was when we had aerial drones mapping the wave. We discovered the development of plumes that were being generated by the wash from some of the vessels that were operating, particularly the wave surf boat vessels.
How do I stop the audio? He's gonna comment on this.
There you go.
That's what I'm looking for. All right.
And then is the video. Is it supposed to be through right now?
It shouldn't be.
Oh.
There we go. All right. All right,
31, 21. That's where we're at. We're stuck in that glue.
I don't know why it looks like it's selected. Should we just restart it again?
That's what I was just thinking. If you wanna open.
The video we're showing you is actually from our phase 1 presentation. So there we go.
So this is live video feed now. So if you watch the waves coming in from the surf mode operations, here you see the development of these plumes. So the wave energy is scrubbing the bottom, lifting off the sediments, creating these what appear to be clouds that are subsurface that move with wave energy to the shoreline. They run the shoreline from south to north. And as they get to the edge of the greenery, they jump over the reef and redeposit on the other side. So as I said, at the end of the summer, 2 summers in a row, we measured that with submersible drones and saw a significant buildup of deposits sufficient to just smother out all the plant life, the fish habitat, et cetera, et cetera. So a subsurface impact without question. We don't have the video to show you here. The video is compelling, but it was hard to get it transferred over. Top left on this one is the beginning of the season in May 2021. The bottom, and again, we've got video that it's like you're sitting on the bow of this submersible 12 feet under the water, running along the bottom. It's all covered up. It kind of looks like Mount St. Helens. Nothing can grow. All the plant life is covered up with this dust. So this is an equipment list of the stuff we used in the study itself, from the kind of vessels that were used to measure wave enhancing impacts. 2020 and a 2014 Nautique wakeboard boats with ballasting as indicated and the engine size, horsepowers. The various measuring equipment that I spoke with you about, the prop wash measuring system we engineered, YSI probes for dissolved oxygen and temperature at varying depths, standard secchies, the surveyor's stick. We measured distance from shoreline with a laser link Doppler effect. We had a Lawrence X100 Charlie Delta depth sonar with temperature and speed units equipped. We have our own patented subsurface measuring system, our own drone, so to speak, that sits on the bottom with cameras and lights. Then we use that 5-fish, I'll show you a picture of that in a minute, which is a movable submersible drone with cameras and very powerful lighting. And then laboratory procedures as I described, surface dips for the total suspended solids, staggered depths for dissolved oxygen, and all the phosphorus samples were surface dip sampling systems. So what did we find? Because we want to give a lot of time for questions here. So these are the principal findings. There are many more, but these are the principal ones for purposes of our discussion today. 1, there are significant differences noted between wave characteristics and impacts of wave action from various kinds of powered vessels. Less impact wave effects are noted, as you would expect, from pontoon boats, fishing vessels, and personal watercraft, as opposed to wakeboard boats in surf mode. Wakeboard boats in surf mode have both surface and subsurface impacts. When that industry says that these vessels do not produce impacts different than other powered watercraft, it is simply not true. 2, the propeller downwash characteristics that we've measured show significant bottom effects in surf mode at depths greater than 20 feet. They have the same data being generated out at Payette Lake in Oregon. That depth effect is not observed from the other common vessels that operate on these lakes, pontoons, fishing boats, ski boats, personal watercraft, because their stern angles and prop wash features are not the same. They're horizontal vortices to the surface as opposed to something that goes down. 3, nearshore impacts from wave propagation show significant differences between vessel types at staggered distances from shoreline, at measured distances as far out as 300 feet that we reported to you today. Wakeboard boats in surf mode produce wave oscillations larger than all other categories. That effect is particularly notable on lakes that are shallow or that have a shelf like the Little Basin on North Lake. 4, bottom impacts from wakeboard boats in surf mode have a significant impact on redistribution of sediments and nutrient release into the water column. After periods of less than 30 minutes, we measured a 25% increase. That's measured in depths of 5 to 8 feet. Water quality measures are responsive to boating activity levels with increased evidence of total suspended solids, particularly during periods of high boating activity on weekends as opposed to midweek. That's all boats. That's not just wakeboard boats in surf mode. And finally, re-deposition effects are notable from persistent wakeboard boat activity in surf mode on the Little Lake Basin, with evidence of plume deposits along the majority of the Wildwood Point Reef. The depositional materials appear to have an impact on aquatic plant life. The phase 3 portion of this study will involve the sewer pack subject matter experts in marine biology and hydrology, looking at all of these data that I presented and talking specifically about its impact upon fish habitat and subsurface impact in terms of aquatic plant life. So we're going to stop here and see if you have questions for us. We're happy to take them.
Is working enough? If it is, we have a question. That's still not a good question.
So the question I have is your phase 1 or phase 2 study published? And if it is, where can we find it? And if not, we have plans to publish it.
The question was, is the phase 1 or phase 2 findings published yet? The answer is no. The reason it's not is because we're waiting for the guys at Sewer Pack to jump in on their opinions, and then we're going to get it into a refereed journal. The information you're seeing, as well as the preliminary reports, are available on the website for the North Lake Management District.
Great question from the board.
Thank you. I was just wondering, about the ballast water that's taken into the stir. If there's a boat like this that goes from one lake to another lake, are disinfection procedures that are used to clean out the ballast, any environmental species? I'm thinking specifically about river level. Is there concern about that ballast compartment? Can that actually get disinfected is my first question. And then my second question is, can you think of, is there any size of a lake that is large enough to accommodate?
Okay, so that's a two-part question. The first was whether there's any kind of disinfectant system that would preclude contaminating other lakes if the vessel floods the ballast and pulls out with all that weight and goes to another lake and then disperses the ballasting. The answer is I don't know whether the system exists. The question also implies, are the operators of these vessels willing to be compliant with something like that? And I don't know the answer to the question. We didn't measure it. I can tell you that many of the owners of these vessels, their teenage kids run the vessels, they don't. And when you go out to speak with them about, do you realize how big a wave is that you just swamped that pontoon boat? You get an argument or an apology. One of the things that Ted Rosa spoke about this morning quite eloquently was you need to change the culture on a lake and get people to be compliant with common good. On North Lake, we went over to talk to Kurt Culver from the Culver's restaurants all over the state. He lives nearby. And I talked him into giving me 200 or 300 little chits that you could use to go buy ice cream at no cost if you behaved properly. And I would go out on the lake and pass those out to wakeboard boat operators saying, you're doing a nice job staying in the middle of the lake, 400 or 500 feet away from the shore. I still have quite a few of those left. Let me just add that as an anecdote. The second question,
Size of the lake.
the size of the lake. Our data shows that you're getting impacts as far down as 20 feet. So that tells me it ought to be a lake that's got sufficient depth that should be beyond 20 feet, number one. Number two, our measurements of wave energy went out to 400 feet. The University of Minnesota study, St. Anthony Lab, shows 500 feet where you still get significant wave energy near shore impacts. So you need to take a measurement about the size of a lake. Clearly, if you extrapolate, small, shallow lakes are not a place to operate these vessels. Did I answer your question, ma'am? Yep.
I think we have time for maybe one more question and we've got one more question.
So the question is there regulation proposed to regulate the use of personal
So I understood that question to be, are there regulations being proposed for operation of wake surf mode vessels on small lakes? It depends upon the lake. It's a very small number that have successfully passed a local ordinance. When there's any visibility to the effort to generate an ordinance, there are rather energetic lobbying groups that get involved from the marine manufacturers associations that oppose it.
And unfortunately, I think that's all we have time for.
There's one more.
As far as, well, we really do need to get.
Oh, okay, sorry.
We can leave 'em up.
Yeah, we'll catch them outside.
We do have, and I think you're probably gonna mention the sign up sheet. Let me get onto the, so that the online people can hear me.